Hey everybody, this is Gregory from Dapp University. So welcome back to this multi-part tutorial series where I'm showing you how to build your own crowd sale, real world crowd sale that can be used to raise real funds in a real ICO on the main Ethereum network. Check out the previous videos in this series if you haven't already, and be sure to subscribe to the channel to see the next video in the playlist whenever it comes out. This episode is presented by QuickNode, the fastest and easiest way to run your own Ethereum node. QuickNode lets you run a personal cloud-based Ethereum node in a flash without having to download any blockchain data or keep it in sync. Sign up at quicknode.io today to start running your own Ethereum node in no time. What we're going to talk about in this video is finalizing the crowd sale. So when the crowd sale is over, we actually want to allow people to transfer their funds, and we want to handle whether the goal was reached in the crowd sale, things like that. So I'm going to go ahead and start Ganache to start running some tests. So let's take a look at the crowd sale we've been developing. And remember, this is a refundable crowd sale. So we'll use that as a point of reference, fundable crowd sale. Let's do refundable crowd sale, actual Solidity file. So if you look at this is a finalizable crowd sale. So we'll open that file too. And whenever we have this finalizable crowd sale, which is what we're getting a refundable crowd sale and a finalizable crowd sale. It has a finalize function, right? That can be called by, an administrator. This is only the owner. And if it's finalized, then finalization is true. It emits a finalization event, and it calls this, finalization function. We can only do this if it's not already finalized and if it, hasn't closed, or if it has closed. So what we want to do is basically write our own finalization logic. We'll override this function inside of our contract, and that's what we'll do today. So I'm going to go ahead and do that. I'll create a finalization function here. I'll say function finalization. And I'll say it's an internal function. And I'll pass this. And I'll go ahead and create our comments like we have for other functions here. Just paste this in. So basically this enables token transfer. We want it to enable token transfers, and we want to call it whenever the owner calls finalize. And we'll do more than that. We'll probably fill this out more. But yeah, this is going to be our starting point. So inside of here, we basically want to say, if the goal is reached, we want to do, some stuff. We want to, we'll talk about that in a minute. But if not, we're not going to do an else condition. We're just going to say super finalization. So it's going to call whatever finalization logic is inherited by this contract. Which, if you look at the refundable crowd sale, it's going to also handle this. So it's going to say if goal reach, it's going to close the vault. And if it's not, then it's going to enable refunds. So if you look at the refund vault, closing it transfers the funds to the wallet, and that's if the crowd sale is successful. If it's not successful, then it enables refunds. It basically says that, hey, this is now refunding, and investors can come call this refund function and say, hey, give me my ether back. All right. So if we, so that's what we want to do. So if the goal is reached, we do the similar logic. We want to fill this in. And if not, we're just going to, super finalization, let refundable crowd sale take over and, do its logic that it's, already filled in. All right, so let's go ahead and compile this, see if it compiles. All right, that worked. So let's go ahead and kind of start filling this out. The things I want to do today are basically say, I want to, so this is a, if you remember, look at our token, Dapp token. This is a mintable token, and it's also a pausable token, right? And remember, we also have a minted Crowdsale, right? So how this works is like with our minted token, what we want to do is basically, stop the minting process whenever the Crowdsale sale has finished. So we want to do, if the goal is reached, we want to finish minting the token. Basically, that means that we're not going to be able to create any more tokens after this. And we also want to unpause the token. Now, this might be unfamiliar to you because we haven't actually paused the token yet, and I'll explain that. So remember, let's go back to our contract. This is a mintable token. It's a pausable token. So the minting behavior is we create tokens whenever investors purchase them in the crowd sale, but we don't want investors to be able to just take the tokens during the crowd sale, before it's finished, and go dump them on an exchange. We don't want them to be able to just take them and run. And also, we don't want people to do that from the pre-sale phase, right? If the pre-sale tokens are getting sold at a discount, someone could just buy tokens in a pre-sale, and as soon as the public sale hits, they could instantly make a profit, right? By just selling it on an exchange or however, right? I mean, that's assuming it's listed on the exchange during the public sale. I realize all that, but just for lots of reasons, we don't want investors to be able to transfer tokens during the sale. So when we deploy this smart contract, we're actually going to pause the token because it's a pausable token. And whenever the goal is reached, we're going to unpause the token and allow people to transfer tokens. And whenever the goal is reached, we're also going to finish minting so the total supply can't change. And I don't think we'll get to it in this video, but we'll also mint the tokens for the founders, the advisors, and things like that. All right. So let's do that. Let's first handle the minting. So we'll say we need to get a reference to the mintable token. So I'm just going to open that. And actually, let me just go ahead and pull in all of the references to the tokens. Let me just paste this in here. So what I did here was imported the ERC20 token, the pausable token, and the mintable token from OpenZeppelin. So I'm going to save that. And I'm going to say down here, I'm going to actually get a reference to the mintable token. Say it's a mintable token. So basically, I'm creating a new variable of type mintable token because we're importing, this contract here. Mintable token equals mintable token. This is going to basically create a reference to this and pass in the token address. Remember, we passed in the token address here, which is ERC20. And if you look at Crowdsale, we've got token is available to us as a public variable. So that's what we're referencing here. This is the token address. And we're basically saying, hey, get a reference to the mintable token smart contract at this address, and we're assigning it to a variable. So now we can interact with a new mintable token smart contract address. It's going to have all the behavior that mintable token does, and we're storing it to this local variable here. So we can finish minting the token like this. We can say mintable token, finish minting. Oops, sorry. So let's look at that. All right. So finish minting. And only the owner can do this. And remember, we transferred ownership of the crowd sale during this testing scenario. So at this point, the crowd sale is the owner. So they're the only ones that can actually finish minting the token. All right, so now let's write some tests for this. We'll say describe finalizing the crowd sale. I'm going to open this up, copy this, paste it here. And we'll also do a couple different things. We'll say, when the goal is reached. All right. And I'll copy this and say also when the goal is not reached. All right. So let's handle the goal not reached first. Basically, let's do a before each function that says we're going to contribute some amount to the crowd sale, but it's not going to exceed the goal. And then basically we'll fast forward to the closing, like past the closing time of the crowd sale, and then we'll finalize it from the administrator. So we'll do that like this. Let's pass this in. So let's step through this. So we're not going to meet the goal. We're going to say await this.crowdsale.buy tokens from investor 2, and we'll say 1 ether. This is way less than the crowd sale goal, and we'll do this from investor 2. We'll fast forward past the end time. We'll say, increase time. This is the same helper we've been using. To this closing time plus 1, just past the closing time. And then we'll finalize this crowd sale. So we'll say await this.crowdsale finalize. So we'll write all the examples that show what happens whenever the goal isn't reached. So here, we're not going to worry about finishing minting just yet. We're actually going to look at the refundable crowd sale. Oops, sorry. Let's see here. So basically, if the goal isn't reached, it's going to enable refunds. So we can try to, let's see here, refund vault. We can try to call this refund function, and it should work if the crowd sale isn't successful. So we need a reference to the refund vault in order to do that. All right, let's see. We can import that at the top like this. Here next to our, we have the refund vault already actually. We did that in a previous video. So we'll go to the refund vault. That's right, because we tested to see if they could claim refunds during the crowd sale, and they can't. So we'll just test against that. We'll say that they can't claim refunds, that they can claim refunds if the goal isn't successful. So we'll just paste that example in. All right. So it allows the investor to claim refund. So await this vault refund, investor 2 from investor 2 should be fulfilled. All right, so let's give that a shot, see if it works. Try to run these tests. All right, it passes. So that's good. We know that the investor can claim refunds if the crowd sale isn't reached. Now what we want to do is say, that handles basically like, this case, this super finalization. That's really the only piece of behavior we want to test. Now what we want to do is like actually test if the goal is reached. We want to say that does it mint the tokens? So we'll go back to our tests and we'll create a new, before each function that happens inside of here when the goal is reached. And we'll just paste this in. So I'll explain this. Basically, when we attract we don't need this just yet, but we'll keep it there. We're just going to keep track of the current wallet balance for now. But here's really what we want to pay attention to. We want to actually meet the goal. So we'll say this.crowdsale buy tokens from investor 1 will contribute. The goal is 50 ether. I want to do an even amount from each. 52 is going to be over, which is what both of these are going to add up to. The reason I'm splitting this up between investors is like you only get 100 ether with each account, right? Whenever you start up Ganache, so you can easily run out of funds and have to restart Ganache all the time. And we'll probably actually transfer some funds to this investor, because investor 1 is using a lot of examples, so that'll give you more time to run your tests. Like you could potentially write a bunch of tests where you're throwing ether around and like never be able to finish your test suite because one of your accounts runs out. So that's why I'm splitting this up. Anyways, so we're gonna meet the goal. We're gonna send it over. The goal is 50 ether. This is gonna be 52. It's gonna be over. We're gonna fast forward past the closing time, just like we did here, and we're gonna finalize the crowd sale, just like we did here. So inside of that, we're basically gonna say just going to copy this. We'll say it handles goal reached. Because we're actually going to use this and create a big old test with lots of lines. So I'm just going to do a generic test for that. So basically, I'm going to say that it tracks that the goal was reached from the crowd sale. And just say goal reached equals this crowd sale that goal reached, because that's what happens in the refundable crowd sale. So that could be true. So let's also say that it's finished minting the tokens. I can say that like this. So it finishes minting the token. So minting finished. Await this dot token dot minting finished. This is a function that's available on the mintable token. And minting finished should be true. And we also, if the goal is reached, we don't want them to be able to claim a refund. So we're going to test for that as well. Let's basically say this. We'll say prevents the investor from claiming a refund. So this .vault.refund, just like we did in this example. Instead of saying it should be fulfilled, we're going to say it should be rejected with EVM revert. All right, so let's save that and run it. Actually, before we do that, I'm going to transfer some Ether to investor one's account because our test might fail. That's pretty easy to do. Let's just create a new before function here. So before each is going to run before each test example. Before is only going to run the first time we run this entire test suite. So I'm going to say await Web3 ETH send transaction from the admin who deployed this to investor one, and I'm just going to give him 25 Ether so that he has a little extra and that we don't run out by the time we run all of our test examples. All right, so I'm going to save that and run these tests. All right, that passes. So the last thing I want to do for now in this video, as far as finalizing the crowd sale goes, is we want to unpause the token. Well, in order to unpause the token, it needs to be paused first. So let's go back to our test, and we'll pause the token so that tokens can't be transferred. I'm going to say, basically in this kind of setup that we did here at the top, I'm going to pause the token. Let's do that right after it's deployed. So as soon as we deploy the crowd sale contract, we'll pause the token. So we'll say await this.token pause. All right. So we'll save that. And let's make a test for this. So we don't want people to be able to transfer tokens during the crowd sale. So let's say like after buying tokens, right? Let's do it right before finalize on crowd sale. Just say describe token transfers. So I'll explain this. So it reverts when trying to transfer tokens. Let's say does not allow investors to transfer tokens during crowd sale. So basically it's going to buy some tokens, this.crowdsale buy tokens from investor one, and it's going to try to say this.token.transfer to investor two from one token from investor one, and it shouldn't work. So it should fail. All right. And we're going to change this to where they can transfer tokens after the crowd sale's been finished. So let's test. All right, that passes. All right, now we want to actually unpause the token. So that's pretty easy. We have, pausable token here. So we can create a reference to it. And we're actually going to pass a token in, right? And see how I did this here with mintable token, right? And I assigned it to a variable. And the reason I did that is we're going to do more stuff actually with the token here. We'll say do more stuff. We're actually going to mint, in the next video, we're going to mint tokens for the founders and the advisors and stuff like that. So that's why I assigned it to a variable. We're going to do stuff with it. But the pausable token, we don't really need to assign it to a variable. So for gas efficiency and things like that, and also just brevity, I'm just going to go ahead and call the unpause function directly here. Say unpause. All right, just save that. Okay. So I'll save that, and I'll run this test. Well, actually, we don't have a test for it yet. So we'll go back to the test suite and write a test for this. So basically, when the goal is reached, we want to unpause the token. We'll just do that here. Let's paste this in. So we'll pause the token. We'll say pause. Await this token paused, and at this point, pause should be false. All right. So let's So let's restart Ganache. Now pay close attention here because you might see errors where you run out of funding. That's because you need to restart Ganache before you start running the test at this point because, you're spending 26 Ether from this account. So you're also spending, lots of other Ether in all these test examples. So you might run out. So that's why I'm restarting Ganache. All right, now we're on the test. All right, it passes. All right, that's it, guys. That's all I got for today. So that's how you create a finalization function on the token sale. We're going to continue building this out in the next videos where we'll actually mint tokens for different funds. We'll have a founder's fund or an advisor's fund and things like that. Check out that next video when it comes out. And until next time, thanks for watching Dapp University.